Okay, let me talk about end-to-end network defense conflict. Um, Sorry for the interruption. Uh, so network defenses were originally set up to preclude malicious entities from entering a network space. And for most enterprises at this time, the defense builds upon a clear concept of the fortress approach. Many of those requirements are based on inspection and reporting prior to delivery of communication to the intended targets. These inspections require decryption of packets when encrypted. This is in contrast to an end-to-end paradigm where known good entities can communicate directly with each other in confidence. We look a minute at the traditional approach, which is based on 20 years of refinement, was originally developed to counter the um, growth of the internet in the early days and the number of nefarious activities that were going on within the internet. Most enterprises set up a firewall, which is the front door that I show in this particular setting here. That front door, that firewall, was supposed to stop the bad guys and let in the good guys. Um, every communication that happened in the enterprise, either external or internal, had to go through that front door. With the major exception, of course, is that the administrators thought that was too onerous, so they developed backdoors and allowed them into the thing. The fortress model assumed it was hard on the outside and soft on the inside. The boundary should not be penetrated, so IT systems should allow access to anything inside the enterprise if you made it through the outside boundary. Over the years, this has been reinforced continuously with the actual upgrade to the firewalls. They added packet inspectors, application-aware filtering, host-based analyzers, etc. The trouble is that these usually cut off a particular threat category, but the threat got more resilient and managed to penetrate. So the threat still continues to penetrate. One of the major problems with this process is that each one of these rack-mounted devices you see here, these what I call pizza boxes, are millions of dollars in some cases because they have to operate at the speed of heat and they have to operate on all of the traffic that comes into the enterprise. Here's an actual enterprise front door if you think I'm exaggerating. The main problem, of course, is that as it comes in the front door, the actual communications are decrypted so that they can be inspected. And you see the number of stops that this particular requester needed to go through in order to get to his application, which is on this other end of the problem here. The real problem is 20 years of fortress development has failed, and you can see all these breaches that we have coming here from enterprises, including ones that you think would know better, like the CIA and the IRS and the White House. OMB, which is the government facility, all have been hacked. And in fact, most people have been hacked at this particular time. Some people don't know they've been hacked, but most people have been hacked. To counter this, a new approach has been developed by a number of individuals that are trying to counter what's going on here. They're variously called by various names: a distributed computing approach, endpoint devices, enterprise level security, and that ultimately leads to the buzzword for today, which is a zero trust architecture. All of these use a seamlessly encrypted end-to-end communication approach that is counter to the basic premise of the fortress approach. Unfortunately, the fortress approach has been around long enough to require reporting requirements that can only be satisfied by content inspection. Content inspection requires breaking the end-to-end communication. So the question of the day is, how do we resolve this dilemma? Pardon the signposts here, but they help me keep track of where I'm going. We'll start with distributing the defenses. We'll look at know the players, provide unbroken end-to-end communication, enforce access and privilege, maintain integrity and accountability. And then finally, we'll talk about how to meet those inspection requirements at the application server. The first thing is the derived system should move from a front door fortress approach to a distributed defense. In this distributed defense, we get rid of backdoors, we get rid of passwords, we get rid of all of the invocation of services that happen through a front door. We still have to go through that front door because the front doors are there available and it's a kind of a legacy thing. But we do not give the private keys to the front door so that it cannot decrypt analysis. So it can do anything it wants to traffic analysis as long as it doesn't decrypt and look at the content. Next step is to be sure we know the players as we go through here. In our experience, we need a bilateral end-to-end strong authentication. In the ELS system that I talked about earlier, we use a PKI certificate, and the PKI certificates are exchanged. These are in the open, and our front door recognizes PKI certificates from 2 known whitelisted entities and tags that as passed directly to the final endpoint. Once those certificates are exchanged, a TLS, transport layer security, is set up. Let me get back on track here. Okay, the next step, of course, is to provide that unbroken end-to-end transport layer security, and everybody in between the user and the application is a passive entity, and it does not deal with the content of what's going on. So the next step is to enforce access and privilege. Access and privilege have been separated from identity. In the case of ELS, we do that with SAML tokens. The SAML tokens are not single sign-on tokens. They're tokens that have actual access and privilege claims. The next step is to maintain the integrity. Within the TLS, we need the recipient of a message to know that what is received is exactly what was sent. Know the content has not been tampered with. This is done by message authentication codes. So that means TLS 1.2 or greater. Those message authentication codes actually will be decrypted to give you the hash of the message so that you can verify the integrity of the message itself. The next is enforce accountability. This is for the ultimate case where the threat is part of our system and we need to recover. So we need to get accountability. We need to know where threats get into the system as part of the recovery system. And then finally, we need to meet those inspection requirements at the application server. So many of the inspection requirements are legislated and we have no choice. So I've shown once again the path through the front door as we go through here. What we do is we dissect that path and we create a boundary of what we call a pseudo appliance. So we come in the front door, we take all of the inspections that need to be done from the front door and create a pseudo appliance, which is a software appliance at this particular case. That software appliance is then injected into the server itself. Here's a diagram of that showing all of the inspections that are done within the server. In some cases, we don't have software only packets. And so we have the handler here is going to pass it off to an external device so that that inspection can be done. So we have a number of handlers in the server itself. We have a number of handlers in the service itself to handle the inspections and reporting as we go through. In summary, we've provided an end-to-end approach that allows for both network inspection and reporting and the maintaining of unbroken encryption. For our enterprise operations, providing a clear end-to-end approach means reduced attack space. And the approach also reduces bandwidth requirements, cost requirements at the front door of the enterprise, and may reduce a number of requirements for load balancing. That's the end of the brief. I'm ready for questions if you guys are still online.